Hi guys, it's OG Petya and welcome back to my YouTube channel, and today I would like to present you the SUI blockchain. So let's start with some short introduction and what is SUI blockchain. SUI is a cost-effective, high-performance blockchain that supports smart contracts right out of the box. Recent tests show that the validator running on 8-core MacBook Pro on M1 is capable of handling up to 120,000 transactions per second. This speed and minimal block latency makes SUI one of the fastest blockchains in the world and capable of serving billions of Web3 users. SUI is trying to solve the blockchain trilemma by focusing on scaling a wide range of applications and meta-universes, including games, social networks, and e-commerce. I would like to tell you a few words about the mechanics of the network. So SUI is able to keep the gas prices low and predictable while motivating validators to process transactions, preventing attacks. This is achieved through validator voting at the beginning of each epoch. Validators vote on a network-wide gas price uses benchmarked for sending transactions for processing. Validators are given incentives to keep the gas prices close to the benchmark price for an epoch. Those who provide higher gas prices, however, are penalized with discounts. The same goes for validators who refuse to transact, and they risk slashing or even losing the coins that they are delegated with. In addition, predictable gas affects the expected number of transactions, allowing the network to anticipate and distribute the load. Gas prices can remain low even during periods of high activity because SUI can scale linearly and the number of servers per validators. Validators can proportionally add more machines to meet increased demands on the network. Traditional blockchains often use only one server per validator. And right now, a few words about the payments for data storage. A unique feature of SUI's design is that the fees for storing information inside the blockchains are paid separately from the execution of the transactions. The cost of storing data within the network are determined by a governance vote and are calculated in the dollar terms. For the users, this all goes seamlessly as both free fees are paid in one, and when the user sends data to the network, they pay both gas and storage fees. A portion of storage fees goes into the storage fund, which covers the cost to validators of storing users' data. The fund is used to subsidize future increases in storage costs as the network grows and develops. Users can also remove data from network if they wish, lowering the cost of using the blockchains for themselves. Therefore, there are two types of transactions on SUI blockchain. First of all, there are simple transactions, which are executed in parallel rather than sequentially, and they do not require validation from the entire chain of validators. Therefore, faulty validators do not reduce network TPS in any way. Transactions of this type are in the vast majority on the network. They are typical for users who just want to transfer assets between two accounts. They do not require any additional confirmation and are almost intentionless. And there are also complex transactions, defined as interdependent and intertwined, interacting with many addresses. This type of transactions is executed sequentially with narwhal. This type of transactions takes 2 to 3 seconds. One of the most important questions for blockchain is which type of the consensus is used. And in SUI blockchain, the BFT consensus is used, which is also known as narwhal and task. SUI's consensus mechanism minimizes the exchange of data needed between validators to process transactions to reduce latency within the network. The SUI's consensus design differs from the most projects in its memipool. Narwhal or memipool protocol is characterized that memipools are stored and confirmed blockchain transactions until they are confirmed by consensus protocol. Narwhal's job is to translate transactions to consensus while maintaining the data availability. Narwhals is interdependent of the consensus protocol and is capable of allowing asynchrony in the form of failures or periodic loss of functionality. On the other hand, task, also known as asynchronous consensus protocol, is responsible for the ordering of transactions. Task uses general randomness to eliminate additional communication between nodes and allows each node to determine the overall order of transactions. Combined with Narwhal, it provides high performance when failures occur. Narwhal and Task can also be implemented in other Byzantine failure tolerance (BFT) consensus protocols. The team has open source code to allow the broader cryptocurrency community to benefit from their research. In theory, the project has no bandwidth scalability limit, but there are also no full test network results yet. It will be interesting to see how it works in practice. SUI is able to withdraw bad network conditions or DDoS attacks on the network validators because they're unable to desynchronize the network. So all of this technical data is amazing, but what about the actual performance and productivity? On the screen you can see the requirements for SUI servers compared to other blockchains. Additionally, SUI launched an open testnet on June 29, and so far the following data has been made public. The network has reached 120,000 TPS on the 8-core MacBook Pro, 130,000 TPS when Narwhal was complied using hot stuff cited as empirical evidence in Misten Lab consensus study, and 160,000 TPS when Narwhal was complied with Task. Also, I would like to mention the programming language that is used for SUI blockchain. Move is a programming language created during the development of the DM blockchain. Unlike other blockchain languages such as Solidity, Move offers a separation of scripts or transactional scripts and modules. Splitting scripts allows you to add more logic to your transactions and make them more flexible, saving your time and resources. Splitting modules allow developers to extend blockchain functionality or implement custom smart contracts with different options. The next important topic which I would like to cover in this video is the SUI tokenomics. The SUI is main network token, and it will be used for staking and security of the network, transaction fees, storage fees, liquidity index, and governance voting. And the total supply of the SUI network token will be 10 billion. I would like to mention that there will be no deflation or burn mechanism. Additionally, I would like to present to you the creators and the team that stands behind the SUI blockchain. So, Misten Labs was created by the Novi research team at Meta, which also worked on the DM blockchain. SUI is no way related to Meta, even though it was formed by former Novi Meta employees. Misten Labs developed SUI's own high-performance and L1 proof-of-stake blockchain. The whole team before Misten Labs worked at Novi Research. Among them are CEO Ivan Cheng, former head at Novi Research and director of engineering at Meta. Prior to that, he worked for 10 years at Apple. Sam Blackhair, CTO, chief engineering at Novi, focused on the movie programming language. Additionally, Edeni Abidun, CPO, former product manager for Novi and Meta. Previously worked at VMware, Oracle, Nova, HCBC, and JP Morgan. Additionally, on the screen you can see additionally team members from the Misten Labs. So, lastly, I would like to talk about the institutional backers of the project. And the Series A took place in December 2021, and during this series, the project has raised $36 million. Among main investors were A16Z, Cribble Ventures, Redpoint, Lightspeed, Coinbase Ventures, and others. Additionally, there was also Series B that ended in the July of 2022, and during this series, the project has raised $200 million. And one of the main investors in Series B was FTX Ventures. Right now I'd like to draw some bottom line. The L1 blockchain market is still very young and competitive. SUI, with its stellar team and new approaches to scalability, is definitely capable of carving out a niche. There are no final test network results yet to compare it with other competitors with confidence, but the pre-final true output results are very encouraging. But we must remember that the technical performance is not the universal recipe for success. Marketing, the ability to attract users, developers, and the liquidity also play a big role. And as we can know, only time will tell us the truth.